Okay, so everything that we need to know for section 2.5. We're going to look at this equation. And the first thing that I might ask you is, what is the degree? Look at this equation. What is the degree? 4, yeah. And then another thing I might ask you is, what is the leading coefficient? What's the leading coefficient for this? Come on. Close, not 9. -9. That negative is important because now if we're going to do end behavior, yes, Caitlin. Oh, yeah. So that negative part is important because if we're going to do end behavior, we're going to have to know that our degree is even and that our leading coefficient is negative, so that we know that the graph will have ends that both point down. So to write end behavior, we use the symbolic version where we're going to talk about where the ends go, which is the y values, which is the f of x. We're going to say f of x approaches negative infinity as x approaches negative infinity. And then f of x approaches negative infinity as x approaches positive infinity. So the parts that I'm highlighting right now are the exact same for every single time I ask you to do end behavior. Those parts will always be written exactly the same. As x goes to negative infinity, who remembers what that means? So x is going to negative infinity. The x number line is going to negative infinity. What's that mean, Malachi? Louder. Yeah, to the left. That just means the left. And then as x goes to positive infinity, that would mean to the right. So as we have the graph going to the left, we talk about what the y value does, and that's down, negative infinity. And then as it goes to the right, what does the y value do? Down, negative infinity. So those are the only things that change each time, are those negative infinities for the, or positives for the f of x. So we kind of know what the ends should look like. These are all things that we don't need our calculator for. The next thing I could ask you would be the possible rational, and I might call them roots or I might call them zeros, but we're going to talk about the same thing. Zeros would be, we have an equation and f of x equals 0. Roots would be, there's just no f of x, but they're exactly the same thing. Like you can see on my wall over there, they're next to each other. Functions have zeros, expressions have roots. The answers are exactly the same. The factored version is exactly the same. It's just one has an equal sign, the other doesn't. So it just depends. It would probably be zeros for this one. So that's the P over Q. Plus minus P over Q. Yes, plus minus, you have to write. So we're going to look up here. Our P value is 20. And our Q value is, I'm going to write 9 because the plus minus does not matter. We're going to put them all as plus minus. So I'm just going to write the 9. If you're going to forget, just write -9. That's fine. So what are my factors of 20? 1, 2, 4, 5, 10, and 20. Factors of 9, 1, 3, 9. So to write plus minus P over Q, I'm going to start with 1 on the P's and do every single Q. So plus minus 1 over 1 is 1. Plus minus 1 over 3 is 1/3. Plus minus 1 over 9. So I used all the ones. Now I'm going to use the 2's. Plus minus 2. And then I do 2 over 3. And then 2 over 9. And the 4's. Plus minus 4. Plus minus 4/3. Plus minus 4/9. Okay, my 5's would be plus minus 5, plus minus 5/3, oops, thirds, and plus minus 5/9. We okay so far? All right. My 10's, plus minus 10, plus minus 10/3, plus minus 10/9, and then my 20's. Now, if instead of using like the 1 over all 3 bottoms, some people will do all of the P's over each Q. You might do it in a different order. That's okay. And then one thing I want to say about this, and it didn't happen in this particular question that I'm going over, but in the question that I went over in my previous class, which I still have up, it did happen. So I just want to call attention to, while you're doing your P over Q's, here's the P over Q's they had. So just looking at the very beginning of their work, if I did 1 over 1, then I did 1 over 2, then I did 1 over 3. There's the first 3. Oh, and 1 over 6. Sorry, I didn't even see the 6. My hand was in front of it. And then after that, when I go to do the 2 and I did my 2 over 1, there's the 2. But my next thing was 2 over 2. And what happens if I have 2 over 2? That's 1, and I already have it written there. I'm not going to write it a second time. And then I would do 2 over 3, and then I do 2 over 6, but 2 over 6 is 1/3, and I already have that written. So if they do reduce them. If they're repeats, don't write them twice. Okay, so those are all the possible rational solutions. If it is rational, if it can be written as a fraction, those are the answers. So it's quite a few, but it's less than infinite answers. The next thing that we learned was positive, negative, and imaginary. So because I'm trying to zoom in so you guys can see really well, I'm just going to copy this equation over instead of looking at the one that's written above. I mean, you could use the one that you already wrote down. So remember, for positive, we're going to look between each terms and see where they change from negative to positive or positive to negative. Anytime we have a sign change. So from negative 133 to positive 64, that is a sign change. From positive 64 to positive 20, that's not a sign change. So I only have one positive. And remember, that's a max. I might have 0 positive. That's a maximum. To do negative, we have to first find the equation with negative x plugged in instead of x. So we do negative 9, negative x to the 4th, minus 74, negative x to the 3rd, minus 133, negative x squared, plus 64 times negative x, and plus 20. I'm going to simplify that. Anytime we have an even amount of x to the 4th or x squared, an even amount, that's not going to change the sign of the number in front. If we have an odd amount, that will change the sign of the number in front. And so then I do my sign change. And from -9 to +74, that is a sign change. From +74 to -133, that is a sign change. -133 to -64, that is not a sign change. And from -64 to +20, that is a sign change. So we have a maximum of 3 negatives. Then we're going to make a table. Positive, negative, imaginary, and I'm going to put my degree. The maximum positives was 1. The maximum negatives was 3. What's my degree? So if I have 4 for my degree, then that could be 0 imaginaries. Now, we know the maximum positive negatives. We don't know anything about the imaginary, except there's one thing we need to remember about imaginaries. Do you remember, Kevin? Say it comes in pairs. Okay. So what does that mean for my chart? What does that mean for my, oh yeah, Kevin. You said one's positive and one's negative. Is that what you said? I can't hear what you're saying after 2.
You got 1, yeah, 2 imaginary. You have 1 positive,
Yes.
1 negative, and 2 imaginary.
Can I have 4 imaginaries? Yes. What do I know about imaginary numbers? I can have what about them? What kind of even number imaginary numbers? I can't have 1 imaginary number because of what Kevin's saying. We have a plus and a minus. So that's 2 of them. They are always in pairs, but we could have multiple pairs. So these are always even amounts. Even amount of imaginary. So knowing that I can only have evens, I could think of a scenario where I would have 4 for the degree, but I would have 2 imaginaries. If I have 2 imaginaries, I'm going to have less positive and negatives. So what could I have? Could I have 1 and 2? 1 plus 2 plus 2, that is not 4. So no. What could I have? Could I have 0, 2? Yep, that would equal 4. There's other scenarios. 1, 1, 2, is that what you said? Yep. Mm-hmm. Anything else? Are there any more with 2s? Or is that it for the 2s? Is that it for the 2s? I'm sorry, 2 imaginaries. So then I think you guys said 0, 0, 4. Is that what you said? That would work also, 0, 0, 4. So when we're finding our positive, negative, imaginary table, these are just like the 1 and 3 are the maximum, but you could have less. So there are 4 different scenarios we could possibly have. So when you're done, and this is what I had students doing in class on the work time today, I'm supposed to have 1 negative, but I got 2 negatives or something like that. Like if you know your max and you're getting more than that, obviously something's wrong. So that's a good thing to have just for checking everything out. All right, so we did that. Positive, negatives, okay. So at this point, everything else we will need our calculator to get us started on. So if you haven't graphed it yet, please get it graphed on your calculator. What happens if you don't bring a calculator to the quiz? What happens if you don't bring a calculator to the quiz? Has anybody not brought a calculator to the quiz before? We don't know? Okay. Do you think I'm going to loan mine out? I'm not going to. So if you don't bring one, you're not going to have one. No, you can't use Desmos. So we need to make sure that we come to class with a calculator. If you don't own one, find a friend. If yours is dead, get it charged. I got a charger over there. If yours takes batteries, get some batteries. Okay. And I also have that other charger that you could use too. Okay, I already have this one graphed, or almost graphed. Okay, so I'm looking at my graph. I definitely see that there are 4 zeros. So if there are 4 zeros, will I have any imaginary? Nope. So I know there's no imaginaries. So that must mean I have 1 positive and 3 negatives. That's my scenario where there's no imaginaries. We can see that on the graph. Okay, the first one, does that first one kind of look like it's an exact integer? It does to me too. So let's do second trace and pick value. This is a short way. If I think it's -5, I'm going to type in -5, and it will tell me, yes, it is -5. -5 is a 0. So I'm going to go back, and I'm going to kind of write down what we're doing. If you're writing things down. If you're not, that's up to you. But I'm going to write down, let's see. We graphed using our calculator. Find a 0 by using the value or 0, which I'll show you that again as a review, or you looked in the table. Because I know some people look in their table to find a 0. If you're having any trouble with your calculator, should you just wait till I'm done 10 minutes later and then ask? No. You should say, hey, I'm having trouble with my calculator. Can you take a look at it? Are you having trouble? Here, bring it up here. I'm going to write one more thing.
What you said about, like, if it's imaginary, how you know it's imaginary with the graph?
With the graph, you won't see it. So
If it's not 4 going to the x line.
right, if you don't see 4, then you're missing some. And you can only be missing even numbers. So if you're only missing 1, maybe your window just needs to zoom out a little bit. Did I fix it? I think I fixed your problem. Yeah, you had like the exponent clicked by accident. There was nothing filled in, but it didn't like it. Okay. All right, so I just wrote, we're going to use our calculator, we're going to find a 0, and then we're going to divide that 0 out. How do we divide out the 0? Always. When would we use, you said it right, when would we use synthetic? When it's an integer. Divide out the 0 by synthetic division when it is an integer. When it is an integer. Or by long division when it is a fraction. So we're using synthetic division if it's an integer. We're using long division if it is a fraction. You see how I said nothing about decimals? Why? Say it again, Caitlin. Yeah, I don't want you to have any. So if your decimal you find is 0.5, turn it into a fraction 1/2. Okay? All right. So that's what we just did. And we found, what number did we find? What did we just find? What was it? -5? -5. Okay. So we'll do our synthetic division, -5. And I've got -9, -74, -30, 133. And then 64 and 20. So we do our synthetic division by adding these and then multiplying. And then adding. Multiplying. Adding. Multiplying. Adding, multiplying, adding. All right. If you saw on your calculator, yep, it's a 0, and then you do your synthetic division and it doesn't give you the 0 for the remainder, that's just telling you did something wrong in your synthetic division. Because if it tells you on the calculator it's a 0, then it should work. All right. This was 4th power, 4th degree. I took out one of those factors, one of those powers, and now we are left with 3rd degree. Do I have to go back to my calculator? Yes. And we go back to our calculator and repeat that until when? Until it's quadratic. Repeat the process above until the degree is 2, which is quadratic. So we're going to repeat that process until the degree is 2. So now we need to go find another 0 from our calculator. And I promise you, every single time you're going to be able to get out enough zeros that you're left with a quadratic. If you're not getting enough of them out, you're missing something. Okay, I promise you I'm not giving you any that won't work that way. I mean, in real life, sure, but not for this. We're just learning how to master this. Okay, it's not mastered yet. So this next one, I already know this one's -5. The next one, I'm going to use my 0 to find it. So I'm going to go do second trace, and I'm going to do number 2, which is 0. And it asks for the left boundary. So I need to pick something to the left of this, which -4 works. So I'll type that in and hit enter. And then it puts that boundary line. And then something to the right, looks like -3 would be to the right. And it puts a second boundary line. So you are telling the calculator, only look between these two. And then you're even going to be nicer to the calculator and you're going to say, I think it's around -3.5. Hint, and you're going to hit enter. And the calculator will tell you, well, this is the 0. Is it -3.5? It is not. Does that look like a fraction that I can find by looking at the decimal? Like I can find that fraction easily? No. So it's probably irrational. If I can't find it easily, I mean, it might be a fraction that we can find, but to me, I'm thinking that's probably irrational. Oh, also, you guys see how this is like 6e to the -11 thing? Okay, we literally just did the 0 thing. This should say 0. I don't know why the calculator will do this on occasion. It's like point, and then there's like 11 zeros, and then the number 6. I don't know why it does that, but it is 0 if you see that. Okay, I'm going to work on the next one. So I'm going to do the left-right thing for this next one. Second trace, 0. My left boundary, I'll choose -1, enter. And then my right boundary, I can tell it doesn't go through 0. If you want to be safer, you can go to like 0.5. I'll just do 0. I think it's a safe bet. And then guess maybe -0.1. It is not -0.1, but it is -0.2222222. 2/9. See how helpful that is? That's really helpful. 2/9. Okay. So we have a second 0. Yay. So I'm going to have x equals, oh, it was negative 2/9, right? Negative 2/9. This is a fraction. So if it's a fraction, we're going to be using long division. So to use long division, I need to change this fraction so it isn't a fraction anymore. Multiply both sides by 9. I get 9x equals negative 2. Add the 2. And then 9x plus 2 is the factor that we will be taking out. I am not going to go back to the original question. I want to go back to the third degree, not all the way back to the beginning. So it's in red at the top. I just didn't put my x's back in it because I didn't know that I would need to. But if it's a third degree, then it'll be negative 9x to the third. See how we're basically reviewing everything we've done in this chapter in one question, except for quadratics. Well, kind of quadratics though. All right, first thing I'm going to do is divide 9x into negative 9x cubed. If you can't do that in your head, then you just write it off to the side, literally put them on top of each other and tell me what you get. Negative x squared. We distribute that back in. So I'm going to get negative 9x to the third. We distribute it back in, minus 2x squared. Then we draw the line, and instead of subtracting them, I add the opposite. So I change the signs. That's my subtraction step. So I'm adding the opposite. I get negative 27x to the third, and then we bring down plus 12x. The next one, I'm going to do negative 27x. That's not to the third. You guys stop me. Come on. X to the second, sorry. So I got negative x, 27x to the second divided by 9x. I divide those, I get minus 3x. Distribute, negative 27x squared minus 6x. Draw the line, change the signs. Add them together, 18x, bring it down, plus 4. One more division, 18x divided by 9x is 2. Distribute, 18x plus 4. When I subtract those, I get a remainder of 0, so I've done it correct. If you don't get a remainder of 0, you've made a mistake. So I have negative x squared minus 3x plus 2. We're still solving. We're down to quadratic. So when you get to a quadratic, maybe I should actually write this part first. Hold on. I'm writing out all the directions because I want to make sure everybody is ready. So when we have a quadratic, use, what are options to solve? Ladder. Factoring, my favorite. Complete the square, your favorite. No. It actually is easier sometimes, but not always. Or the song. Quadratic formula. So that's basically your choice at the end, except factoring doesn't always work. So you won't always be able to use factoring, but you can always use the other two methods. So what did I have? Negative x squared minus 3x plus 2. Is that what it was? Somebody help me. Okay, good. What should we do? Take the negative out, factor. Okay, so then I will have x squared plus 3x plus 2. Yes, minus 2, thank you. That would have been bad. Now what? Are you trying to factor it? You're trying to factor it? Is that what's happening? We're trying to factor it? So we got x and x. I'm going to have one positive and one negative. Oops, that's not negative. I'm going to have one positive and one negative so that my negative 2 will, these two numbers will multiply together to give me negative 2. But it doesn't matter where I put my 2 or my 1. There's no way it's going to add up to be, oops, maybe. It's no way that when I multiply it back together to get a positive 3. There's no possible way. So that tells me I cannot factor this one. I have to use a different method. So you guys want to do quadratic formula? Okay. Good, because complete the square for this one is not a fun one. If the center is even, complete the square is super easy. If the center is odd, or if you got other numbers here, it's no fun. All right, so we are doing quadratic formula. So x equals opposite. Oh, which one do you want to do it with? The top one or the bottom one? You want to do it with the bottom one? Okay. No, it's fine. The bottom one. Just kidding. It doesn't really matter because the negative 1 that came out doesn't affect any of the x-intercepts. It just affects the signs. So if you're going to do it with the bottom one, you're just going to use this part. So x equals opposite b plus or minus square root b squared minus 4a negative 2c all over 2a. So I didn't use the negative. I'd factor that out. I'm not using the negative. Negative 3 plus or minus square root 17 over 2. Well, that's lovely. I'm just going to rewrite it right here. Now, here's where before when we were doing the assignments, it doesn't really 100% matter which way you do it. I was trying to keep it so we have no fractions. If you imagine trying to type fractions into Canvas, kind of sucks, especially when you're trying to type that fraction in Canvas. So to get rid of the fractions, if I just multiply both sides by 2. Now, I'm sorry, that's not for the 0, but for the factor, getting rid of the fractions. The 0, you're going to have fractions. So you can't really do anything about that. But for the factor, when I go to make this equal to 0, I could multiply by 2, and then I would have 2x equals negative 3 plus or minus 17. And then I would move 2x, I'd move the 3 over and make it plus 3. Then I'd move the plus and minus 17 over, and we'd still have plus minus 17, square root 17 equals 0. So that would be our factors if we got rid of the fractions. If we didn't get rid of the fractions, then we could have x, and we're going to move this stuff over. It's going to become plus 3 plus or minus square root 17 over 2. But we will write those separately when we write them in factored form. Like right now I have them together, but in factored form, they will be written separately. Okay? Is my speed okay? Can I go to a different part of this? Have you guys gotten that? I can't talk today. Have you copied it down? Okay. Somebody has. All right, we're good to go. Let's see how much space I have. Oh, good. I wrote much smaller this time than I did last class. So, okay, so we need to write our zeros. And remember, I want you to write the zeros from left to right, or from least to greatest. I say left to right because they are the x-intercepts that I'm looking at on the graph. So if you're using your x-intercepts, it should be somewhat easy to write it from left to right. Or you can just look at the numbers themselves. From left to right, what is our first x-intercept? The 5, right? Yeah. So we'll have x equals, then we'll have -5. And then the next one was irrational. We skipped that one. And the third one was, what was that? 2/9. The third one was 2/9. So the irrational ones, one of them is the bigger one of them is the smaller one. So when I look at plus minus, which one's going to be the smaller one? Lydia, if I'm looking at plus or minus, or here, plus or minus, which one's the smaller one? Which one's smaller? Yeah, I'm actually pointing to the wrong place. So I'm sorry if that was confusing. When I'm looking here, the minus will be the smaller one. When we look at the factors, it's opposite. So we're going to have -3 minus square root 17 over 2. Then we have our -2/9. And then we will have -3 plus square root 17 over 2. Now, if you are unsure which one's bigger, just type this in your calculator. Like on the regular screen, type in the calculator and look at the decimal. I don't want you to stress out about that. You have your calculator. Type it in and figure out what order they go in if you're unsure. So those are our zeros. And then factored form, we will have f of x. And our first 0 is going to correlate to our first factor. So we will have x plus 5 for our first factor. And they are opposite of what the 0 signs are. So this next one, I did solve it, but I put ors. I put like two versions. Here's factor or here's a factor. So I'm about to do 2 versions of this so you guys can see. We'll do the one with the fraction first. So this one has +3. And then it's going to be plus square root 17 over 2 because it's like the factors are opposite of the zeros. And then we will have our 9x plus 2. And then we will have x plus 3 minus square root 17 over 2. So those would be the factors. And then last class, there was something that we talked about that you have to check. You'll look to see if there's any stretch or shrink or reflection, if there's any number. So I just left a little space there. So how do we check that? Brady, do you know how we check it? Okay, so before you do that, I would have to plug this entire equation in to check that. There's a faster way. When we were doing it, I wanted you guys to see they weren't the same. And we can always check it by looking at the 2 graphs on top of each other. But there's a fast way of looking at it right now to determine if I'm missing anything up front. Who remembers that? Grace?
You take you can put percent from the first equation and the derivative is that, and then you multiply all of them together and see if it matches the same leading coefficient in the absolute version.
Okay, so what Grace is saying is she says, go to the original, which we had -9x to the 4th. So I'll just write that over here. And I'm going to multiply all of these first terms. I'm going to multiply x times 9x times x. And that should be the same as -9x to the 4th. But it's not. So what do I need still? We need the negative. We'll put that out front. Put it in black so it looks like it's part of the answer. So that's just a double check. Now, if you want to triple check, you can also graph. But that could obviously take longer. I mean, that's yucky to type in. Now, I told you I wanted to show you with using the fraction. I also want to show you if I didn't use the fraction irrational one, I'm going to show you that one as well. So that one would be, if I do the factored form for that one, I need to zoom out some. Come on. So put or factored form here. So we would still have that, oops. We would still have that x plus 5. And then the next 0 would be 2x plus 3. And then plus square root 17. Then we would have 9x plus 2. And then we would have 2x plus 3 minus square root 17. I ran out of space. No, I didn't. I just didn't scoot it over. Okay, so if I write it that way and we do the same check, that it is negative 9x squared. We'll get x, 2x, 9x, 2x. So I would get 36x squared. So out front for this one, what would I have to put? Negative 1/4. I think that's what somebody said. That's what I wanted to hear. Negative 1/4. But both of those are totally fine. Either of them is totally fine. When I'm doing the assignment for the review, I was trying to put like both answers there, depending on which one you wanted to do. And there's one more thing that I wanted to show you before we move on to the actual assignment. Why didn't I get the negative for either of these? Why wasn't the negative there? Say it louder. I did factor it out earlier, and I never did anything with it. Remember, we factored it out right here? We factored it out. That is a factor. It should have just gone in front. And I didn't say anything because I want you guys to see, you know, you can still find that negative even though we took it out. We put it back in at the end. But that's why it wasn't there when we actually had our end, because we factored it out at some point. Okay? In your assignment, there's 9 questions. And I told you already, only 9 questions, 8 pages. Most of them aren't very long. Even though I gave you like a whole page. I do know that I think it's number 4 is a little long. Did you already start? Yeah. So number 4 is a little long, but that doesn't mean 5, 6, 7, 8 are. I just like number 4 is. And then one thing I want to say about the assignment. Where is my assignment? I was working on it. Is this it? Is this it? This might be it. Yeah. So one thing I want to say about the assignment, when you do starting at like question 6, it says to find the possible rational zeros for any 2 questions from this section. There's 4 questions in this section. You only have to do 2 of them. If you want to do more, there's more for you to practice. I will do it for every single one. And then it also says the possible positive, negative, and imaginary zeros for any 2 questions. It could be the same 2. You could do the P and Qs on 2 of them, do the positive, negative stuff on the other 2. I don't care. Just practice it twice. Okay? You guys have the rest of the time to work on this.